Hello everyone. Today I'm going to present you what I have been working last week. That is like a new redesign of the strategies framework that is more focused on the signals and how you generate and customize your algorithm instead of working a lot in the execution. So the idea now is that I will try, or the people that wants to create new executors are going to develop high efficient algorithms to execute logic in the market. So the idea is that the execution logic will be like abstracted for you, and you need to focus only on the signal and what you want to trade. So the end-to-end cycle will start in the dashboard. In the dashboard, you can get market data, create your strategy based on some rules that you need to follow. And once you do that, you are going to be able to create a strategy, backtest it, optimize it, and deploy it with just one click into a Hummingbot instance. That is like the whole goal behind this new design. Well, I hope that it is good for you guys to start creating like more complex strategies. Today I'm going to introduce the market making framework, but I will give you some ideas of what the strategies B2 framework looks like. Okay. So, well, market making. Usually, if you know what is market making, this is like the most common strategy. You place two orders around the mid price, and you are trying to capture the volatility. I like to identify, well, this is something that the father of market making, as I call it, that is Nico Baum, told me that the first time that I started learning market making, you can abstract the risk in two main risks. The first one is the price risk, that every time that you are holding an asset that is volatile, for example, you are holding Ethereum, the price of Ethereum can change, can go up and can go down. So by holding the asset, you are exposed to some risk that you have to figure out how you're going to manage that. Probably you like the exposure and you are not going to do anything. If you don't like the exposure, you're going to place a short or probably some trick with options, trying to hedge the position all the time. So well, that is how you are going to manage the price risk. And the inventory risk is a huge problem in market making, and a lot of papers are trying to solve this, like for example the paper of Avellaneda Stoikov, because when you are placing the two orders around the price or the 10 level of orders, or well, you can place how many orders you want, every time that you get a fill, for example a buy order, your inventory is changing. So if you have a lot of fields of buy orders, for example, you are going to start holding a lot of base asset, and that is a huge risk in terms of exposure. You have a lot of exposure in your inventory. So there are several ways of managing this or trying to improve and control the risk of your inventory. And another important thing is that this inventory risk also affects the price risk, because as the inventory that you have of base asset is changing all the time, if you want to hedge, you will need to figure out how to update your hedge. Are you going to update the hedge every X time, every day, or if the inventory deviates this X percent or whatever? So there is a lot of complexity, and that is why doing market making is something like really hard, and is more like for professionals, and the individuals usually goes for, I don't know, grid strategy or directional strategies, because they are much more easier to understand and also to control what is going to happen. So after thinking about this and running a lot of bots, because before I was working in a hedge fund and I have this issue, reading the book of Marcos Lopez de Prado, understanding why Stoikov was trying to rebalance the inventory, I have an idea to refactor how the market making is done in this strategy that I'm proposing, and treat the market making as each order level, as I mentioned, as I write in the code, is independent. So this is the proposal of, well, market making demand, and the idea is that instead of placing two orders and the orders are going to be matched or taking profit, who knows why or how, in this case each order will have an end state. So if your order is time, for example, you have to refresh the order, the order is not going to be valid. If the order was executed, now you start with a position executor. And for example, in this case, here we have the graph. In this case, I was running a bot with a lot of order levels, but what I'm trying to explain is that this level, for example, will have a take profit and stop loss. So every time that I take a position, it will be closed by take profit, stop loss, or time limit. That is something that obviously you have to tweak the parameters, or based on the market that you are trading on, you have to figure out how these ranges should be, because if the time limit is very short, you are going to rebalance your bot very frequently. There are a lot of things to care about that we are going to talk in a while, but the whole idea behind this is that each order level is independent, and by that we have a lot of benefits. First of all, by using the position executor, the same strategy works in spot and perpetuals, because how the position executor works is that if you are in perpetuals, it's easy, you have a long or a short, but if you are in spot, this will be selling the asset and trying to buy the asset in a lower price, or buying the asset again here. And that is like the main difference. And that is how the same strategy that you are writing works in spot and perpetuals. The second benefit is that it's very easy to hedge. Why? Because as I mentioned, every time that I start a position, it will be closed at some point via take profit, stop loss, time limit, or another thing that I didn't mention is early stop. Is that if you have another condition that involves the behavior of multiple level of active orders, you can, for example, make the cumulative P&L and then close all the positions with an early stop. That is possible too, but I don't want to enter in that now.
Well, one clarification question just for the audience, because market making, you're placing orders. So it's basically, when you say position executor, the strategy will place orders, and then if they're filled, basically they'll become positions, right?
Yeah.
Sorry. That's kind of why it works on both spot and perp.
Yeah, sorry, I didn't explain that, and it's really important because the position executor is one object that I created in Hummingbot this year that is like an order that has, in this case, the order is placed and it's a position executor. The position executor has an open order and a closed order. If the open order wasn't filled by the time of the refresh order, the position executor will be marked as close type expired. If the position executor the order is taken, you will have to figure out which is the barrier that is going to move you out of the position later on.
So kind of like just explain it on a high level for the audience. These executors are kind of like self-contained pieces of logic. In this case, it's kind of placing an order and then managing how to change that order afterwards. And this is kind of why it's suitable for backtesting and for downstream other applications. We're basically separating the generation of the signal as to when to place or to keep orders from how to manage the order itself. And so because we're separating those two pieces, that will allow us to have more control over each one and to basically create templates that help non-technical coders optimize each part of the strategy.
Yeah, and just to explain a little bit, the position executor is the first smart component, as I call them, because imagine that you want to do a directional trade. You will need to create the order, store the order ID, check how many amount was filled, see if the P&L, which is the percentage of the P&L, if you have to close the position via stop loss or stop or take profit or time limit, execute the opposite trade, and then check that all the orders were right and no one fails. So all that stuff that is a lot of execution is abstracted for you. You just need to create the position executor with the configuration of which is the entry price, which is the stop loss, which is the take profit and time limit, and it will do all the work in the market for you. That is like the idea behind these smart components. So, well, going back to the benefits of this approach, I was in the easy to hedge. As I mentioned, every time that I take a position, the opposite trade will be executed at some point. be a take profit in the best case, stop loss or time limit. That means that the initial base inventory will be the same, or with some variations depending on the profits that you are making, but the percentage will be very close to the initial percentage. So it's really easy to hedge that, because you just put a short, for example, of Ethereum for the initial amount that you are trading of Ethereum, and at some point the inventory will be the same, so that you don't have to modify the short position of the hedge. That is one really cool advantage, because trust me that doing hedging is really complicated and very cost. You have a high cost if you are doing that very frequently. The inventory risk disappears also for what I mentioned before. Every time that I take in a position, I'm going to close that position, so I don't have to manage the inventory. That is a huge win of this new model. The other thing is that we have explainability of each action. In the past, when you are running a market making strategy, you have a lot of buys and sells and buys and sells. And how do you know if you are making money or not? Which order is paired with the other one? There is a lot of, it's very difficult to explain what the bot is really doing. So this gives you like explainability of each action, because at the end you're going to have a CSV with each position executor, the end state, the entry price, the P&L or whatever, and then you can match that with the market data and understand what happened there. And also leverages the AI research, because as we have explainability of each action, this will drive to a lot of like ideas that can come up to create AI algos around this. So now let's review the strategy framework. This is going to be a little bit complicated. I'm not going to enter in too much details, but right now the strategy framework has two main things. This is in a branch that I'm going to show you later on. We have, in the first place, the executors. As Mike mentioned, we have the position executor and the arbitrage executor. The idea of these smart components is that they are low level, they abstract the trading logic for the user. It's a task with multiple steps, because as I mentioned, position executor will create a position, check if the position is filled. Once it's filled, calculate the P&L, see if it's time to close or not. If one order fails, it knows what to do and whatever. So it has a lot of multiple steps, but once all the steps are completed, it is no longer like alive. It's going to be, has a start and an end. So just to summarize, it will be a component that you are going to create, and it will have a start stage and an end stage. What it's going to do, abstract a lot of the trading logic for the user. The good thing is that it is easy to configure, because you just need to create the object and say in the configuration which are the things that you want. And the other cool thing is that improves the scalability of the strategies, because imagine that you are writing a strategy and then you want to change something or create 2 orders instead of 1. You will need to create like a lot of logic, and your script will have, I don't know, 200 lines, and with the position executor probably will have very probably 70 lines. One important thing is that before I made this refactor, the direction strategies, they have like 300 lines, and now has less than 70 lines of code, and it's much more easy to understand what they are doing. Well, that is what the executors are. And then we have the meta strategies, that this is going to be like strategies V2. We are working in the naming with Mike, because I'm not so good giving names to the things. But yeah, the idea is clear. It's like the executors, as I mentioned, they are like very specific logic that is abstracted for you. And the meta strategies are going to be strategies. Hopefully they're going to be the new way of defining strategies in Hummingbot in the future. But for now we have the market making strategy and the direction trading strategy. And what they are tasks that they don't have an end, but they can be started and stopped in the main strategy. In a while you are going to understand how you can do this, But just think about this. Imagine that the market is very volatile and you think that it's going to keep in that range for a lot of time. You can run a meta strategy of market making. Then you receive a signal that says the market is going to have a very big uptrend. So it's time to, for example, go long. Then you can stop the market making strategy and start a directional strategy that is trying to go long, for example. So this is like a new workaround. In the same script, you can have multiple meta strategies that are doing different things, and you can start and stop them. So in the future, like the main strategy will be orchestrating different sub-strategies, or no, you can just use just one if you want, and that is one cool advantage. What they're going to do, these meta strategies, they are going to orchestrate multiple executors based on the trading logic. So for example, the market making executor is going to create a lot of position executors of long and short, and based on the conditions of the controller that we're going to see in a while, they're going to stop one executor, start another one, or do whatever they want with the position executors. And the meta strategies has two main components to make it scalable, because here is like a huge benefit that I'm going to explain you in a while. But we are going to have, as I mentioned, the naming is not right now, and if you have some ideas, propose it on the chat. But we are going to have a meta executor that is going to manage or orchestrate the different smart components based on the logic defined the control task. And then we are going to have controllers that are going to provide the signals and conditions for the meta executors. So what we're doing here, we are splitting the execution logic. That execution logic, it will be always the same. For example, the market making, there is one file that is market making executor. That file is not going to change. What is going to change is the controller. That the controller says is like the market making executor will ask, hey controller, what I need to do? I need to create executors? Yeah, I need to create these executors. And it's going to send signals of how he has to do the job, but there are two different components. And the power of this is that once you have this meta executor that is working really good, you can change and generate multiple or different controllers and create strategies or different strategies very fast. That is like the main advantage of this.
Based on this description, I already have, I think, a good sense for how we can change some of the names. The overall idea here is we're going to create these like executors that are kind of these self-encapsulated pieces of logic. They will be parameters. Each one will have a set of parameters you can inject. So those parameters can be injected by the controller and can be optimized and backtested. Meanwhile, the controllers and the meta executors that are part of the meta strategy, they are also kind of componentized. Essentially, we're separating fetching the data that's used, which is the responsibility of the controller, connecting to the candles feed, getting the basically the candles feed essentially has historical data now available to the bot. So that's kind of why this is possible, because the controller can fetch that historical data. It can basically generate some type of signal that's used, whether it might be a volatility signal, might be like a trend, might be something that is going to basically tell the executors what to do. And they'll pass those signals and conditions. The meta executor is going to manage all the components to tell the smart component how to react to those signals conditions, and then the executors do their thing. Because every piece of the strategy is separated, this actually will this kind of sets a foundation for actually allowing users to optimize and control each aspect.
Well, and this graph is really interesting because it explains like the power of the controller, because the controller will generate, as I mentioned, the signals and the conditions. And once you have the signals and the conditions generating from the controller, then we have the meta executor that is in the Hummingbot side that is going to use the live data and create an action for each observation based on the signals and the conditions. It's going to do something in the market. But the same signals and conditions are going to be used in the backtesting that we have in the dashboard, but instead of doing this with live data and action for each observation, it's going to use the historical data, and all these computations are going to be vectorized, so that is why it's going to be very, very fast, and will let you backtest and optimize different controllers that are going to be responsible of generating signals and conditions. So benefits: same code works for Hummingbot and backtesting. This is not finished. I am working on this because it's a little bit tricky to mix and make the abstraction for the controllers. The second benefit is that this signal first. Its execution is going to be abstracted for the developer. You don't have to think how to interact with the Binance or whatever. You just need to focus on the signal. Then we have an atomized logic design via these executors. So we are going to control each detail in the part of the meta executor. And another thing is that multiple controllers works with the same executor. So as executor, I'm going to show you which is the design of the market making right now, but you can generate, for example, a controller that is using for market making the MACD and Bollinger, then another one that is using the RSI, another that is just doing some crazy stuff with the spreads and whatever, and all the different controllers are going to work with the same executor. And that is another thing that I put in the next steps, or benefits of next steps, is that a lot of people always ask, what about performance? I have some opinions about that, but the thing is that these meta executors in the future, if this works and the people accept this new way of defining strategies, can be written in Python. So if we have the meta executors in Python later on, it's going to be really, really powerful, because you are going to have C speed, and well, the signal will be probably in Python, or you can do it in Python if you want. But well, that will be really, really cool. And the last benefit that I think that is the most important thing is that you have an end-to-end development cycle in the dashboard. You're going to be able to create, optimize, and deploy the strategy from the same dashboard, and that is going to be, for me, a game changer for the users. This is the design of the market making framework right now. So we have this market making executor. As I mentioned here, you can find the implementation in the market making executor file. Don't worry about it, because you need to understand how the controller works. That is, for me, the most important thing for you. Understanding how the controller works, and don't worry about the market making executor unless that you want to understand or optimize the execution logic, right? So what you need to define the controller. The good thing is that the controller works at order level. So we are going to have a lot of order levels, and the controller is going to be able to take a decision based on the market conditions, the state of the current order level. So the first one, you will need to define, hey, this order that is here should be refreshed, yes or no. That is really crazy, because now you can code in the controller, okay, if it's the first order, refresh it in 10 seconds. If it's the second order, in 20 seconds. And well, endless things can happen here. Early stop condition, this for now, don't worry so much about it, but imagine that you are receiving the executor and then you are taking a decision based on all the other executors or the active executors, and say, okay, I'm going to close it because the overall PNL of these three positions is positive, and I would like to start over. The cooldown condition is for what we have in pure market making is order field delay. That is, once I start and finish a position, should I wait X amount of time until I start again? And this get candles with price and spread multipliers is the method that will be shared with the backtesting. Right now is the one that we have get signal in the backtesting. That is the one that will let you shift the mid price and make the spread dynamic based on market conditions or whatever, or any signal that you want to do. The get position config, that is the last one, is going to create the position for each level. So this will let you, for example, customize a spread or a position config for each level independent. So this, as I mentioned here, you need to implement these methods that are going to be applied for all orders that the bot is going to manage. And it's very powerful because now you can customize the action at order level.
As a question about that, so the order level, can you kind of explain how you can change it by order
Yeah.
level and maybe why, and also why you would want to change, something, like for instance, how you would want to refresh the orders that are closer to the mid price faster than the ones that are farther away, so and how you would be able to change that in
Yeah.
the just for example, as an example of the like how you would customize it.
Oh, okay. Well, for example, when I was working before in the hedge fund, in the contract that we have with crypto.com, we have a very strict rules. If you check the miner, they are very, very flexible. But in crypto.com, they ask me for 10 level of orders, 30K per side, in a range of 2.5 percentage. The top orders needs to be in 0.15% of distance. And that kind of conditions for a professional market maker are really tricky and they're really difficult to manage. And probably you would like to create a different logic for the top orders, prevent to have an execution. And
Right. Yeah.
another thing is that it's not only now based on time, because you can do it based on distance from the mid price. So if your order is really
Right.
close, you can refresh it now.
So basically, what Fede is referring to is, like kind of like you want to define different, behavior for orders that are closer, like tighter and closer. You may want to refresh them more. You may want to stop them, before, and you may want to define a different behavior for order levels that are farther away from mid price. Maybe because you want to maintain them, even when prices move around a bit more. So the way you can do that is you can use a def, the cool down condition, here, where you would basically define kind of like, basically, and you could use an order level parameter here and say if order level equals 1, here's the condition, change condition every maybe 10 seconds. If the order level equals 3, then maybe only change it every 60 seconds. So basically we will have defaults. We will have default kind of like settings here, but the idea is that as a user, you just need to define and change this file here and change all the position executors and have them do what you wanted to do.
Yeah, exactly. And that is really powerful because I'm going to provide some base controllers, but then you have to create your own controller. And if you want to change this or change, that is really specific what I mentioned, to have a different policy to refresh the top orders and the other orders. But the thing is, what I'm trying to explain you here is that now you can do whatever you want. You can change the behavior of the different level of orders. You can change the spreads. You can change other things for each level of orders. Or you can keep it simple and don't do that and just work with the price shift and the spread dynamic. And then once you start working on this, see how you can improve your algo. This is also a game changer for the grid strategy, because the same model can be applied to the grid strategy. This is going to be a grid executor, for example, and we're going to have an independent grid. But in a while, we're going to see how. So, well, I have some results. As I mentioned, I coded this last week, and I tested on Friday. It was like the last part was like 6 hours of running the algorithm. As you can see, I trade a lot. What I found is that it was working really, really cool. The P&L at the end of the day was like the cumulative between the two sub strategies that I was running was 7%. Obviously, that this is not something that I'm going to tell you, hey, with this strategy you can do 7% per day, because it is a really high result. The things here of the status are not working well yet. I have to figure out, because I have accuracy 100% and I have 2 stop loss here, for example. As you can see, a lot of positions were closed via trading stop, because in the position executor you have the option of trading stop, and I think that is a game changer for market making. It will give you a lot of much more profits than the ones that you had before. And well, I made like 7% in a day, and it's not representative because I should run the bot for a week or a month to see if the results are consistent. But the most important thing is that now the loss is predictable, because you can say each order level, the amount of each order level multiplied by the stop loss that you define will be the maximum loss that you can carry. You should know that when you're running the strategy. If you are trying to test this, stay with the computer while you are running the bot. Now let's see some examples. So this is like the design of the shifted mid price, or how I make it. So first of all, I'm going to use two indicators. The MACD that I'm going to use, this is the value of the MACD. As you can see, this is the histogram of the MACD. This is the value of the MACD. And this is the normalized average true range. What is doing this average true range, that is going to be the one that we are going to use for the first example, that is dynamic spreads, is a measure, to put it in simple words so all of you can understand. It measures like the size of the candle using the high and low, or the previous close and low. You can check the formula if you want, but the conceptual idea that we have is that it's going to give you the average of the candle size that you can have, and it's going to use, in this case, 21 number of periods to calculate that value. As you can see, as here we have a very big candle, this value increases or decreases. And the good thing of this is that as it's normalized, you can use it to set up the spreads, because it's something that, if you think that the average candle size is 0.5%, then you can use that as a spread. And we are going to use the MACD to shift the mid price. The MACD it uses two means and a signal, and basically is checking if the means are converging or diverging. So to analyze the histogram, if the histogram is positive in this way, it detects that it's a uptrend, so the price should be moving up. And if it's red, it starts to be negative, it's going to be a downtrend. So, and as you can see, the MACD has like an increasing and decreasing part. So this is what Druckmann tries to detect, is trying to detect when the MACD is turning down to identify this. But in this case, we're going to make it simple and just say, if the histogram is positive, it will be a long, and if the histogram is negative, will be a short. Yeah. So and obviously we are not going to enter in a short or long position because we are doing market making. But what we are trying to do is to shift the mid price. That is like the idea. And we are going to say that for the MACD histogram, if the histogram is positive, the signal is 1. 1 means, as I mentioned, long. And if it's negative, it's going to be -1. That is going to be short. Then we're going to make a formula to shift the mid price. So and the MACD, if you check some papers or people explaining technical analysis, means that if the MACD is positive and then the histogram becomes negative, this is when you have the downtrend confirmed. So a positive value of MACD means that if the price is if we have a turnaround, it's going to be very powerful, the turnaround that we are going to have, and the opposite side for the long. So we are making transformations to the values. This is a little bit math or nerd math, so don't worry if you don't understand all the things. If you have some questions, you can ask me. But basically what we are doing here, we are doing a standardization. It's a very common technique in machine learning, because what we are doing here is subtracting the mean and dividing that by the standard deviation. So the result of this distribution should be, if the distribution is normal, like this one that is between -1, -3 and 3. And what it has, mean 0, because we are subtracting the mean, and it has a standard deviation of 1, because we are dividing that by the standard deviation. So all the observations should be here between these values, and that is easier to compare between different signals that we are composing. And we are going to make it negative because if it's positive, we are looking for a short, and if it's negative, we are looking for a long. So that is why we are changing the sign of the signal. So all the things that I mentioned is because we are going to shift the mid price in the second example. So to explain you how it works, the dynamic spreads, if and why we are doing that is if the volatility of the market is high, we want to increase the spreads. If the volatility of the market is low, we want to decrease the spreads. So as we are using the normalized average true range, that is the common size of the candles, we are going to use that to set up the spreads based on that indicator. But what if we want to add a shift in the mid price because we have a signal and we are checking, okay, the market is going to be in an uptrend based on our signal. So if the market is in an uptrend, what we want to do is to shift the mid price. This is the mid price. We are going to shift it and say, okay, the market is going up, so probably the next mid price will be here. From this price, that we can call it reference price, as the paper of Avellaneda Stoico, they are doing something really similar, but instead of doing it with technical indicators, they are doing it with the inventory imbalance, the trading activity, and the volatility. But as we have the previous mid price here, now we have this new reference price. We're going to put the spreads around this new price, and that will make that the buy order is closer than the current price, and the probability of execution of this order is much more higher. And that will be really cool for us because we are saying that the market is in an uptrend. So if we can fill this order, and then when the price goes up, the position executor will be here to capture that profit and make the money for you. What happens if the market is in a downtrend? We're going to shift the mid price down, and this order will be here, and this order will be here, so the probability of the sell order will be much more higher, and then boom, we're going to buy again based on the configuration of the executor. So this is why we want to do this. And how we are going to calculate this shift on the mid price? Well, first of all, we're going to calculate the normalized average true range. That will be the first example that will be helping us in setting up the spreads. And then what happens? If we have this thing to shift the mid price, how much we can shift the mid price? Because if we are shifting the price in higher value than the normalized average true range, this sell order probably will be here and will be executed as a market order. And we don't want that. We want to shift the mid price in a certain range. So for that, we're going to define a max shift. That is going to be normalized average true range divided by 2. This means that, for example, if we are here and this is the normalized average true range, the shifted mid price can be between this and this place, because it's going to be normalized average true range divided by 2. So this mid price can be shifted up to this price or up to this price. That means that the buy order can be placed at maximum at here, or the sell order can be placed at maximum at here. So this is going to be how we are going to shift the mid price. And then what we are going to calculate is the MACD value. And then we're going to compose the signal. Here I'm giving a 0.5 weight to the signal of the histogram. So if the histogram is positive, this will be 0.5, because histogram will be 1 if it's for long. And the signal of the MACD multiplied by 0.5, because as I mentioned, this will be standardized. That should be a value between -1 and 1. And the result of this will be a value between -1 and 1. Why? Because imagine that signal MACD is -1, so we'll be completely short, and signal of the histogram is -1. This will be 0.5 multiplied by -1 plus 0.5 multiplied by -1 equal to -1. Obviously, this is not a strict, can be -1.2 because the standardization doesn't stay between -1 and 1, probably can be between -3 and 3 if you have 3 standard deviations and a normal distribution. but the important thing here is that the value should be between -1 and 1. And that is what we are going to multiply by the max price shift, that is this normalized average true range divided by 2, and that is going to make us the shift in the mid price for us. So, well, you can review the video and ask me any questions about the maths behind this. It's not so complicated, but probably if you are not so familiar, it can be a little bit tricky at first, but once you understand it, it's going to be easy for you. So, well, now let's check the examples. Let me show you where this is located. We have here this smart components folder with executor and meta strategies. We have the base classes for this, that is what we can later on start writing in Python to make it much more efficient. And we have right now the market making framework, where you should change the code or where you should add the code inside these strategies. Strategies are the controllers. We have to change the name. As I mentioned, we are working in the naming. Right now we are not, these are going to be the controllers that we mentioned. For now we have the daemon B1 and daemon B2. The first one is going to be the one only for dynamic spreads, and the second one will be dynamic spreads plus shifted mid price. Each controller will have a configuration. In this case, as we are doing the dynamic spreads, the configuration, also you have to define the strategy name, and in this case we are adding the normalized average true range length. So this is going to be the configuration for our strategy. Also, as you can see here, the config base has the strategy name, the exchange, the trading pair, the order levels, the candles config, all the things that then we are going to use in the strategy, or we have to define the strategy. But the things that are specific for this strategy is only the normalized average true range. So this init that we have here is only because if I don't have this, the normalized average true range, the linter is not recognizing the normalized average true range, and this is why I have to redefine it, but it's just this code that you will need to repeat. And then let's check how I define the conditions. The refresh order condition, I am checking the position config, the timestamp of the executor. This is when the executor started. I am adding the order refresh time that was defined by that order level in the controller. And if the timestamp that I created the executor plus the order refresh time is higher than the timestamp that we have right now, we're going to return false. If not, we're going to return true. So we have to refresh the order. If this value is higher, means that the time is not there. So we're going to return, no, you don't have to refresh the order. If the time passed, yeah, true, you have to refresh the order. Then the early stop condition, I didn't implement it, so I just return false. So every time that the algorithm is asking me, hey, should I stop this executor? No, don't do nothing. The cooldown condition, we are checking if we have close timestamp. If the close timestamp plus the cooldown time of the order level is greater than the time, we're going to return true and then false. And then let's check this get candles with price and spread multipliers. So what we are doing here is, first of all, we are accessing to the first candle. In this case, we are going to use just one candle for this algorithm. We are going to calculate the normalized average true range, and we are going to divide it by 100 because it's more like absolute value. And this normalized average true range, as I mentioned, is going to be used as a spread multiplier. Yeah? And then we have the price multiplier. It will be 0 because I don't want to multiply the price, or I don't want to shift the mid price right now. So it's going to be static, and we are going to use the close price for this value. So as you can see, it's really simple. We just define the indicator that we want to make the spread dynamic. Here you can use the volatility, for example, or whatever. You can start doing some testing. And then the price multiplier is what we are going to do. So these are going to be like values that, based on the configuration of the order levels, we are going to use them to place our orders as we want. The last thing that we have to do is get the position config. This position config is something that the position executor uses is like the configuration of the position executor. And we have to define and use the information from the order levels that we have to see how we are going to construct that position executor. So the close price, we have the close price, we have the amount, because the order level, I made a decision. If you want, you can change it for the order level for you. That is that the order amount of the order level is in USD. And I made this in this way because if not, for me, it's really tricky to create configurations for different trading pairs and start thinking, okay, how many tokens I need to place in this order. I think that all of us thinks more like in risk in USD, and you have very clear if it's a huge risk or a low risk to expose $50 than 2,322 tokens of X project, because you don't know the price of that moment. So there are a lot of things here. That is why I decided to use the order level with USD. And here what we are doing is dividing that by the close price. We get the amount in base asset. Then we're going to get the price and spread multipliers. This method is getting this data frame and just returning the last two values. Then we're going to say that the price adjusted is the close price multiplied by 1 plus the price multiplier. This is a percentage. The side will be -1 or 1 depending on the order side. This is for making the spread dynamic. And the order price, that this is what we want to calculate based on the price adjusted on the spread, is the price adjusted multiplied by 1 plus the order level spread factor multiplied by the spread multiplier and the side multiplier. This spread factor is something that you are going to see in a minute in the strategy. But basically, each order level has a different spread factor because we have a spread multiplier. Imagine that says the normalized average true range says that the spread that you need to use is 1%. Okay, you can construct different order levels and say the first level of order we have a spread multiplier of 1. That means that the spread of the first order will be 1%. The second order level we have a spread multiplier of 1.6. So if the normalized average true range is 1%, the spread of the second order will be 1.6. So that is how this abstraction starts working and making sense. And then we need to create the position config. This is the position config that the position executor uses. As you can see, you have to define all these things, and with this information, the position executor will make the end-to-end cycle. Create the order, check if the order is executed, check if it has to close by stop loss, take profit, or trailing stop, or whatever. Well, that is how it's going to work. And then we're going to return the position config. This is one method that I thought that probably can be implemented directly in the base class, but I also think that probably you would like to do something custom here or re-implement the order level to add other parameters. So for now I left this in the controller, in the specific controller, to let you do whatever you want with the position config. So this is how this works. As you can see, we need a configuration, and all this logic will work with the market making executor to do the work for you. So now let's review how we can use this new meta strategy or controller in one script. So this script, as you can see, is inheriting a script strategy base, and we're going to trade on H bar. Well, first of all, I created this triple barrier config. That is the configuration. This is an object that I created. It's a configuration for the order levels. So, for example, you can create a triple barrier aggressive. I think that is 2G here. Aggressive, and then you can create a triple barrier config. Relaxed. And depending on the order level, you can say, okay, the first one will be using aggressive and the second one will be using relaxed. So this is how the configuration starts making a lot of sense. So this triple barrier conf what it's going to do is going to define the stop loss percentage that we are looking for that level, the take profit, the time limit. This is how much time the order will remain in the market until it's closed. So this will be like the last time of rebalance that we're going to have. Then we're going to define the trading stop activation price delta. This means that the trading stop will be activated when the position reaches 0.2% of profit, and the trading stop trading delta will be the distance from the activation price that we are going to start following the price. So if the price goes up, the delta will be following it in 0.05%, and if the price drops, it's going to be execute a market order, so you are going to capture that profit. This is obviously the first parameter that I created. I don't recommend you to use it without supervision, but well, it makes 7% in 5 hours, so it's really cool. And then we have to define the real thing, that is the configuration of the controller. We are going to trade on Binance Perpetual. The trading pair will be HBAR USDT. The order levels here, as you can see, you have to define the level, the side, the order amount that you want to use in USD, the order refresh time, the spread factor. This is, as I mentioned, what we are going to be multiplying to the normalized average true range, and the cooldown time that you want. This, as you can see, can be a little bit strange to define it like this in all the scripts. Obviously that you can do it as it is, but what I'm planning to do is to create a class that will be an order levels builder. So you can build, for example, arithmetic distributed grid, exponential distributed orders. My idea of that class is that we'll create this configuration for you, so you don't have to manage each level independent. But I think that also this is something that you are not going to be defining here, because the idea is that this configuration comes from the dashboard. Then you are going to backtest all the things in the dashboard, and when you press deploy, this will be generated for you. So, well, the next thing is that you have to define the candles config. In this candles config, we are going to define the connector, the trading pair, the interval, and the max records that we want, and the controller will initialize the candle for you. In the future, another improvement will be that I'm going to make a candles manager class that will be a singleton, so all the different strategies can access the same instance of candles. But for now, it's going to create another one, but don't worry. The leverage that we are going to use 10, and the normalized average true range will be 21. So as you can see, this part of here is like the base configuration for all the strategies, and the normalized average true range is like the more specific configuration. The demand B1 strategy, as you can see, the strategy that we show which are the indicators or the conditions. We define here the conditions and how to treat all the things. And we're going to create an instance of the controller. This is a real controller with the configuration that we define here. The controllers has a method that is update strategy markets dict, and we'll be checking which are the markets that needs to be updated to the dictionary and the set of trading pairs. So it's really easy, the code is checking if it exists or not, and if it exists, it's going to add, and if not, it's going to create it, and if not, it's going to add to the set that value. So it's really easy. Well, this is like the part of the configuration of the script. So once we have the configuration, once we have the controller, then we need to plug the controller into an executor. So in the init method, we're going to create a market making executor, and we're going to, well, pass the strategy because it needs a strategy to do the things. And the meta strategy will be this self demand B1 that we defined here. So in the on tick, what we are going to do is, if the status of the executor is not started, we are going to start it, and this executor will be running. And this is also the other power, because here you can say if volatility equal to whatever, then you can self daemon b1 executor dot stop, and then you can pause the executor and do what start, for example, a directional strategy. So this is the other power that we're going to have. And the formal status is only the executor of the market making has a formal status that shows you the P&L, the active orders, the realized P&L, the unrealized P&L. So we are just going to show this formal status. So let's run it. Let's see that we have Binance. We have here H bar. So let's start the strategy, start script, market making, demand B1. So as you can see, it's starting. We're going to run status live too to start seeing. As you can see, we have active executors, level by 0, by 1, sell 0 and sell 1. No active executors. Now we have 4 executors that are active. We can see here that the spreads were defined automatically based on this normalized average true range, and seems like it's a very good estimation of where the spreads should be, right? Because check that you didn't define any specific value for that, and is placing the orders in some place that can be attractive. If we have a very big move, boom, we can capture that. So this is the first example. Imagine that you would like to tweak and say, okay, I would like to be a little bit more aggressive. The top orders needs to be closer. You can go to the script, for example, to this market making demand 1, and change to the first level of order. Instead of 1.5, put 1.0, and now the normalized average true range will be well, this thing that we are seeing here that says realized P&L 5.23. Don't look at this because this is like the main strategy and it's using the CSV that we had before. This is the trading that I was doing the other day that I mentioned. So for now, I have to continue working on the performance report. But well, this was the report of the strategy that I was running the other day. So now if I stop this strategy...
We'll just ask if the total volume reported, is that in the quote token? I think the status that you were seeing, there's like a volume. Was that in the denominated in the quote token?
Yes, in the quote token. Well, as you can see, I stopped the strategy. The orders disappear from here. So now I'm going to start it again, and we should see the top orders much more closer because I changed this spread factor to 1 instead of 1.5. So now let's run it again. And as you can see, the top orders are closer to the close price because we use a spread factor of 1 instead of 1.5. So this is actually, well, how it works. The first example, that is this only making the spreads dynamic based on the normalized average true range. So now let's stop this and let's check this example, the demand B2, that as you can see, we have the same configuration, but we are adding the values of the MACD. The refresh order condition is the same, the early stop condition is the same, the cooldown condition too. And the only thing that we are adding here is some pandas and pandas TA to add. First of all, we are getting the values of the MACD. Then we are accessing to the output. So this is how the nomenclature that pandas TA uses. So the MACD value is this one, and the MACD histogram is this one. And we are, as I mentioned in Notability, I close it, but the MACD signal, here we are doing a standardization. So I'm doing MACD minus MACD mean divided by the standard deviation and multiply that for -1 because it's the opposite signal. The same will happen in the Bollinger Bands, for example. And the MACD signal will be 1 if the value is greater than 0 or -1. Then the max price shift, as I mentioned, will be normalized average true range divided by 2. And the final price multiplier will be 0.5 multiplied by the MACD signal, 0.5 times the histogram signal, multiplied by the max price shift. So let's check some scenarios. Imagine that this is -1. The max price shift will be minus normalized average true range divided by 2. So in the candles that we were seeing here, if the order was here was 1 normalized average true range, the max shift can come up to this price, for example. the spread multiplier is the same, and the only thing that changed here is that instead of passing 0, that here as you can see we pass a 0, we are passing the price multiplier that we are looking for. And the position config is exactly the same. Let's check now the example. Here you can see that it's market making demand B2, H bar USDT we're using the same, this configuration is exactly the same. Instead of having 2 level of orders, here we have 3 level of orders. I am adding 1, this is a level 2. The market making 1 was using just 2 level of orders, and this one has 3 level of orders. And well, this configuration of the candles is the same. How you can update the strategy is the same. The market making executor also, how we are starting, and the performance status is actually the same. This, for me, will be, if we explore this path, will be a refactor of the whole strategy framework. And I think that we should start looking at splitting really well the execution and the data. But well, for now, this is like the formula that you have to follow. Define the configuration, creating the instance of the executor in the init, and starting in the onTick. So now let's run. We are subscribed to the order book, so we have the 3 levels as I mentioned, 3 for buy and 3 for sell. Now we have these executors. As you can see, it's not all the thing. Well, here the total volume was $1,400, and as you can see all the executors because and we have one field actually. One executor is running. Let's check it into the market. Yeah, we have a position and it's closed. Market also field, and we made well, we get a field and we make money. So I was making money live. But well, the performance status is very big, so I can see it. What I'm doing to check it is escape status, and then I am analyzing like the report like this to see how it works. So we have another execution right now running. Well, these 2 orders are like very close to the previous close price. Once it is created, the orders are not going to be shifted. That's another important thing to notice. And if we check the indicators of the MACD, let's open this a little bit. If we check these indicators of the MACD, the histogram is saying us that we are in the signal is buy, and the value of the MACD is also negative. So as this is negative and the histogram is positive, this is confirmed that we are going to have an uptrend. So that is why it puts the buy orders much more closer than the sell orders. And that is why also we have a lot of fields of positions of long positions right now. And actually we take 2 profits of the 2 orders that we started. So well, that is actually how it works. Another cool thing about this is that, or this design is that one level of orders, when it's taken, it can be replaced at the same time, at that moment, with this logic right now. So it's going to be very conservative for you. The second level of order has to be executed before you place the first order if it wasn't finished. So well, that brings a lot of possible benefits later on.
So basically, when you're writing, like at some point, there's like one position, and there were it's like 5 open orders. The strategy was treating the open position as an active position, and so it's not going to create a new order level when there's a position active. Right?
Yeah, in the order level that you have the position active is not going to create another one. Obviously that you can change it, that is my design. But my design for now is, if you take a position in this level, you can't take another one. And this is really similar to how the grid strategy works. Because once you have a level of the grid strategy active, you can't active that level again. You have to go to the level that is below or up there to continue trading. So it's a mix between the usual.
Right. Yeah. So and I think that has a lot of benefits from a market making perspective, actually, because it's kind of like that actually really helps you control your inventory. As you say, I'm only going to have 2 buy levels and 2 sell levels. it helps you kind of make your inventory around a certain level quite a lot.
Yeah.
And another question would be, because right now, obviously, you're doing this on a perpetual exchange. On a spot exchange, if it's a spot executor and you have a fill, how do you kind of like manage that fill afterwards?
Yeah, that is why the position executor is really cool. But for me, it's really cool because I created that. The thing is that the position executor internally handles each position as a position. So if you get a fill of a buy order, that will be like a position that if the price goes up, you're getting a positive P&L, and if the price goes down, you get a negative P&L. So under the hood, we are treating in spot as perpetual positions every time that we are getting a buy order field, or a sell order field will be like a short position because we are selling the asset and we are trying to buy it in a lower price. So the position executor works either for spot and perpetuals with the same interface. You don't have to change anything. Here, if I change, for example, instead of doing Binance perpetual, I'm doing Binance, it's going to work directly without any issues. I'm not going to do it because I don't have a H-bar and I don't want to buy it. So, and also I have the last example to show, but the same code will apply for the two of them without any issues.
One final question on that is in a spot position, when the time limit is hit, what happens?
You sell the asset. If you, for example, if you bought,
it's reverse, right?
Yeah, it's reverse. If you bought one Ethereum, you are going to sell one Ethereum or take profit or stop loss, or you're going to sell it at time limit. So you have a guaranteed rebalance of your inventory. That is like the biggest benefit.
I like that because basically that gives you full control over how that fill is managed. Because you can set essentially that fill, you can set a take profit, you can set a trailing stop, and you can say, okay, at a certain time limit, reverse that trade if you want.
Something that I didn't mention is that you can pass the stop loss, take profit, or time limit as none. So the triple barrier can work without time limit if you want.
Okay, got it.
But you need to define at least one. At least one should be defined because you need an exit for the position executor. Right. So, lastly, the last thing that I would like to show you is that I have this market making demand composed that is a combination of the first example that we saw, that is just spread dynamic because we have this demand v1 config, and we have this demand v2 config that is the second one that has this shifted mid price. And as you can see, we have the first controller that only makes the spread dynamic, and the second one that makes the spread dynamic and also shifts the mid price. I'm creating the first controller, the second controller. I am updating the market's dict. In this case, will be the same market. So we are trading in the same market with two different market making strategies. This is like really powerful because, as I mentioned, you can tweak the behavior of the top level of orders, or you can code two controllers and use one controller for the top level and one controller for the end of the orders, the tail orders. So this is really powerful. Then, as you can see, we're using the same market making executor, the class, but the meta strategy will be for the first one, demand B1, and for the second one, demand B2. And we have to start and terminate the control loop and show the former status for the two of them. So this shows you how you can run two meta strategies, sub strategies, strategies V2, we don't have the name, but you can run two of them or more in the same exchange. So to show you how it works, we're going to open this again, market making demand composed. So now we have this level of orders. As you can see now in Binance, we should see much more orders than we had before. We have a position right now. And well, as you can see, some of them are really close, and this difference should be the shift in the mid price that we are like doing here. So, well, as you can see, the buy order is much more closer than the sell order, and we have like 9 orders and 1 position. That means that we have 10 level of orders. One is active right now, and the second strategy, like the demand B2, has 3 and 3, so that is 6, and the first one has 2 and 2, so we have 4 more. And if we check the status of the bot here, instead of live, let's put it status. You can see that we have 0.1% of unrealized P&L. The first level of the demand B2 is active. Here we have the time limit, how close we are to the stop loss or the take profit or stop loss, if the trading stop is activated or not. Then we have the same information of the performance for the first strategy. So here you can control multiple strategies and how they are performing in the same screen. Well, I found some discrepancies between the reporting of the terminal and here, and I think that the main difference is that Binance here shows you this P&L of the trade P&L only. Here is not considering the trade cost, but in the bot I am considering the fee cost in the position that you are creating. That's all. I hope that you like it. I hope that you can start using it. This is the branch in case that you want to start testing it. Is market maker base. Is a draft yet. And let me know if you have any recommendations, ideas to use here. One thing that also I didn't mention is that this configuration of trading stop is very aggressive, because usually the fee cost is 0.006%, I think, between the buy and sell order, or 0.004. It's 0.304 or 6, depending if you are using limit market or market. This is very close to the fee cost, and this trading stop delta is also really close. But I did it like this to have some trading volume and see how it works. So probably you would like to use a higher value for this activation price delta. And I recommend you to have a higher value here too, because if not, it's really common that the price shifts a very low amount. You have to get rid of the noise to use the trading stop delta. So those are like my recommendations. Yeah, Wishak says you don't have limit. No, you don't have limit. The limit is your computer. So you can add, I don't know, 3 market making strategies, or I used to run direction strategies up to 10 in the same bot using 10 candles feed in a T2 medium. So for the ones that are doing market making, for example, for the miner, they usually use liquidity mining, for example. This will be a game changer for them, because now they can run a strategy with just one bot in a lot of different markets, but with just one bot. And that reduces a lot the need for having a better resources or paying a lot of AWS. Another important thing, if you want to run in multiple pairs without issues, is not using too much limit orders and use more market orders, because every time that you have a limit order, the bot is going to ask for the status of the limit order. And if you have 100 limit orders, probably you are going to start hitting red limits. If you start using, for example, I know one guy that is the king of the grid strategy, and he's using for the grid strategy market orders for all the levels, because he can do grid strategy in 10 or 15 pairs with just market orders without hitting any rate limit issue. That is like another consideration that I'm giving to you. But at first, as always recommend, start small, start with just one trading pair, one strategy, understand how the framework works, and then start scaling your product.
To share my screen, I want to unveil some of the changes we've made to the Hummingbot website. So we've actually launched the new website. The new tagline we're using is a new open source OS for crypto algo trading that helps to do everything you need, from designing a strategy, deploying it, managing all the bots that are running it, and then also backtesting and optimizing those strategies. So hopefully, you'll join us in this new turning point in Hummingbot. Well, one thing I should mention is that this will probably be the last one of these in-depth how-to calls. And the reason is because we'll be turning this type of content into the gated content that's only available to BotCamp members. So in the future, hopefully our energy is spent either, kind of basically building this new framework, fleshing out the features in Hummingbot, or creating kind of like more exclusive content for the folks in BotCamp who are sustaining the foundation. And thank you, Callum. Callum says it's a tagline because this is exactly what we've been building in terms of the base in the community. And I totally agree. Keep on building and keep on having people like everyone here just try it out, use it, and tell us what we can do better. But one last thing. So there's probably a bunch of broken links on the website. We've also moved only like 2 articles from the blog over. But we are going to move over everything in the next 1 or 2 weeks.
Yeah, actually, I was looking at the web page, and I think that looks better this web page than the one that we had before. Like the aesthetics or the things. I think that I like it more this one.
We have a consistent design now. We actually have a theme. Which is here. I'll post this on our site soon, but it's one because I actually incorporated the design principles from this into the new site, whereas in the old site it was done before we had this guide, and so the old one was not as consistent. So this is actually more my fault that I didn't actually kind of. But this time I properly did things the way I learned from Antonio, the Coin Alpha designer, and so now we have proper, I think, more consistent styling than we've ever had.
Cool. Well, there's one question that was missed before that was from Wushak that says why it was between -3 and 3 and not -1 and 1. And this is more like statistics. Usually the normal distribution goes from -3 to 3 sigmas, and you have like the 99.3% of the observations. So that is, you in one standard deviations, you have, I think that 70, I have to remember the numbers, but you have a very, very big quantity of observations in between one standard deviation. In 2 standard deviations, you have like 97 or something like that. Then you have 99 point something. So
there's a few more questions. I'll just address them before we end. One is from Rob. So Rob says, it feels like you're moving away from liquidity rewards with Miner, with less reward programs and more into a pure trading bot. Is that a fair assumption? Yes, definitely, actually. So to explain, Miner is actually run by our parent company, Coin Alpha. They're still working on Miner, but because they also do other services, they also provide other liquidity solutions for token projects. Miner is only a part of what they do. On our side, we really focus on the open source software, but Hummingbot is really expanding beyond just a tool that you can earn liquidity rewards with or do market making with, and more of a platform where it helps you basically build strategies and run them. So the part that we haven't shown, at least today, that much is the dashboard. But in the future, the strategy framework will be kind of like connected with dashboard, so that you can kind of like define a market making strategy template, and optimize those parameters used for the executor and the controllers, and then deploy it. But on the backtesting deployment side for dashboard, we are focused on directional strategies for the time being, because that will focus user experience, and so we won't incorporate this new like market making kind of like framework into that for a little while. And then one more question from Stellar Style. We'll be able to review this how-to. Yes, we are recording it, and this will be probably one of the last how-tos that we will publish publicly on YouTube like this. Well, thank you, everyone. It's been a long one, but I really appreciate how almost everyone in the audience stuck with us. I know we covered a lot of ground today, but hopefully that gives you a bit more insight into how to construct market making strategies that are composable, that are using historical data to shift the spreads and the mid prices, and how you can kind of create one single strategy that is running two sub strategies that are each doing different things. So there's some things you can do, and we will be expanding on this framework and much more in coming months. So thanks everyone, and we'll see you next time.
Bye bye. Thank you very much.